Welcome everyone. In this video I'm going to show you a very simple watering system based on an Arduino. So you can see this huge mess on the table, and I will explain all the different parts. So the main part or the main device is of course an Arduino. So I have an Arduino Nano here in some sort of extension board, so I can screw the pins or screw the wires in these terminals. It's very simple, and it's much more comfortable than just using the board. So we have this Arduino Nano. It's totally sufficient for this kind of task. Then here we have a real-time clock module. It works with I2C, and as you can see, it has a battery as well, so it will remember the time when you are not powering this circuit. We have a LCD here, so we will display some data. We have a on switch, which is for the manual watering, so you can override the software, and whenever you turn on the switch, then you can start the pump, which is here. You can see the signs of use. I've been actually using this for more than half a year. So this was this pump. It's a simple 12-volt pump. It was immersed in a bucket, and then at the end of this tube was attached to the pot, so it was watering my plant every day at a certain predefined time. And then we have this 12 volts relay, or no, it's actually 5 volts, so you can switch it with Arduino, and we use 12 volts to run the pump, but in fact this can be used with the regular power outlets in your house. So it can take 250 volts and 10 amperes. So you can switch anything with it. And then of course we have this 2.1mm DC jack to be able to connect some power source, which will power the Arduino, the screen, and through the relay it will power this pump. And I have to emphasize that this project is not only for pump, but it's very good for anything that you want to switch on and off at a certain time or within a well-defined period. So you don't necessarily have to use this pump with this project, and you can control more relays. You can redefine the timings, but if you build this project and follow this source code, which I will show you later, you will be able to create a circuit which can be run, or which can be controlled via a timer. So you can use the real time and or the date, so every week or every month you can switch on and off anything basically which is connected to a relay. But in this project I will use this for watering. So let me power on this. So it's a simple 12 volt power source, and I just put this screen in the middle somewhere, then I just plug it in. So there will be some fancy message. It will count down, as you can see. So 2019, 12th month, and 15th, and this water is just a text, and false, that means that we haven't watered yet, and then here we have the time. And it seems like it's a bit off by 10 minutes, so I guess that the battery needs to be replaced. But it's not a big problem, so you see that the time is changing properly, but we will have to change the battery, and I will do that soon. So now there is a pre-programmed date, so every day 9 in the morning it will switch on the pump for a predetermined period of time, which is basically based on the performance of the pump, so how much water it can move within a certain time. But we will not do that, but I just show you that I can switch on the pump with this switch, so you can listen. So that's all. So you can see that we have a system which needs a new battery and a timer, and we can switch on and off this pump by using a switch and a relay. So what I will do now is that I show you the source code and explain how you can implement these different things. So let's jump to the source code now. So this is the code here. I just listed the modules or parts that I'm using, and then we have to include some libraries for the I2C, for the real-time clock, for the screen as well. So we have this 16:2 LCD, and then we have this kind of RTC here, and we will define this library with this RTC. So there are a few booleans, which is basically new data. So I have the comments everywhere. It explains quite well what is what. But this is for the serial communication. So if there is something we received on the Arduino, then this will change. And then this is just basically watering. So did watering happen or not? And then this is the same. Did we water today or not? And then I have this variable watering hour, which is basically when we want to water. And now I want to water every day 9 o'clock in the morning, because when I use this system I was already in the office, so I could see if the watering happens or not. So this means that it will water 900. And then watering length, this is basically how long in milliseconds we want to run the pump. And if you see, if we go up, this is the performance of the pump. It can move 240 liters per hour. So every second it can move 0.6 deciliters, which is quite nice. So if we run it for 10 seconds, we can expect more than half a liter water. But we have to consider that we have a tube attached to the pump, and the pump has to reach its final speed. So the actual water which will exit from the tube will be less. You have to play an experiment with this, but 10 seconds for me was okay. And then we have the pin number 2 for the relay, so we will switch this to low or high whether we whenever we want to switch on or switch off the relay. This is for the switch, so we basically just read the state of the switch. So when we switch on the switch, then the software will recognize it, and it will allow the relay to switch on and power the pump. And then this is just the state of the switch, and this is just the character which we send from this computer to the Arduino and ask it to do something. So in the setup, this is just the very basic exercise to start the LCD. We have to define which pin is which. The relay pin is of course an output, and the switch pin, which we read, is an input. We don't need too high speed for the serial, so 9600 baud rate is fine. We start the wire, so the I2C, the real-time clock, and then here we can refresh the real-time clock. So this works in the following way. When you compile this code and upload it to the Arduino, the current time of your computer will be transferred to the real-time module and will be updated accordingly. So for example, if it's 5 o'clock on your computer, then you compile this whole code, upload it to the Arduino. It will be updated in the real-time clock module as well, and from that date the time will elapse accordingly in the real-time clock. But you have to make sure not to make the same mistake as I did. The battery ran out of power and the time was a bit different. So you have to make sure that when you upload the code, you have a fresh battery, and that's all. If you keep the system powered, then it's not a problem because the battery will not be used. But if you remove it from power and put it in your shelf or in the drawer, then the battery will run out of power. Then we just send a message to the serial port to this computer, and then this is just a fancy startup. So we just count down, and that's all. And when we count it down to 0, we will show the main screen. The loop is very simple, so we have 5 different functions or methods, and we will go through each. So we check the serial port here. It's very simple. We see whether we receive the character or not. Here we have just 2 options. If we send a W to the Arduino through the serial port, we start watering, and the pump will run until you don't send the character S. So this is basically a very manual watering. This is just for me for testing this, but you can extend this and have a very good control over your watering system or whatever you control with the relays. Or you can have basically something else. So if you don't send anything, here you can light up an LED light or something, just to have a visual feedback of the status. And then we set this new data back to false, so we can receive a new data again if something happens. Then execute command. So we execute something. So we check the flags, which here is the watering. So if the watering is true, then we have to do the watering. So first of all, we switch on the pump. Then we just print a message. It's not necessary. It's just something which is fancy. And then we wait until the defined watering time or watering length, this was 6 seconds. So then until that goes, we run the relay, and then immediately we turn off the relay and rewrite the screen. So we clear it, and then the default message will be shown, and then yeah, watering is disabled, so this is false again. And then we switch this water today to true. So we say that the automatic watering happened. And here we don't do anything. And then print time, this is basically just the very simple exercise for the real-time clock module. So we just print out the date and the time, that's all. And if the watering happened here, then we just print out true on the LCD screen. If not, then we print out false, so we know that the watering hasn't occurred yet. And then again, this is just the date and time for the serial port. So we can see that the time is moving on the Arduino. Here, this is very simple. We just check the time, and this is basically for the automatic watering. So this is the date time now, so we ask the real-time clock module for the time, and then if first of all we can have this. If the time now is 1 hour later than the watering hour, so let's say we define the watering hour as 9 o'clock, so if it's 10 o'clock now, then we just say that the watered today is false. So if this function runs, or not this, but this function, so the second one, runs on the following day, then it will see that on this day the watering hasn't happened yet, so it will run the watering. So then here is this. If the time now is 9 o'clock and the water hasn't yet, so if the time now is 9 o'clock, so this is this condition here, and the watering hasn't yet happened today, then we run the watering and say that now the watering happened. So this is very simple, and you can print it on the serial as if you want. And then we just check the switch. So this is the manual switch to override the control of the pump. So we read it and we see if the switch is high, then we switch on the relay, so we turn on the pump, or if it's low, so the switch is not on, then we don't do anything. Or we set back the relay to the default low position, so it's off. Therefore we don't do anything, or switch off the pump which was running previously. So this is the wall code. So it's basically 3 different exercises. A real-time clock module, so you read the time and do something accordingly, and it's an LCD module, so you print something on the display and refresh the messages, and pin control basically, so you can read the state of the pins. So this is for the switch, which overrides the control of the pin or pump, sorry. And also you can like switch the pins on and off, and not reading their state but writing their state. And this is for the relay, so you turn the relay on and off. So in my project I use this control to control the watering system, but you can do basically anything which can be made by the combination of these things. So you can pull the curtains, for example, by using a motor, and you switch the motor with a relay, or you can turn the heating on and off based on the day or based on the time. So for example, you arrive home at 6 o'clock in the afternoon and you want to have a warm house or a warm room, so you connect an electric heater to this relay and say that okay, at 5:30 I have to start this heating, so at 6 o'clock the temperature will be warm at home. Or you can do this with lights as well, so you have some lights in the window which you want to turn on according to the daytime, so you can do the same. The only thing is that you have to define the hours. So in my case this is the watering hour, so you have 24 hours time format, and then this means that 9 in the morning you want to turn on something, and it's not necessary to use hours. So here you see this condition like now.hour. This can be now.day or second or month or anything, so you can define your own yeah, as you can see it here. So it can be year, month, day, hour, minute, second. So you can define your own rules, and you can perform some task accordingly. So it's a very good basic exercise, because then you can expand this code and make quite complex projects. So this was all. I hope you learned something and this was useful. And if you have any questions, just leave a comment, and see you at the next video.